Hi everybody, welcome back. So we have the 2252 all assembled and we have it all calibrated and tested, and we did our restoration and it cleaned up pretty nice. I'm very satisfied with the way it turned out. Although it's not my favorite design because how they integrated the amplifier and power supply on the same board, it is the same classic design amplifier and receiver that Marantz is known for throughout the years. Now, a similar one that I use as my bench amp is the 2240. And I like this one. They're both very similar, and when you talk about power and things like that, it's really negligible. They both function pretty much the same. It's just this one's a lot easier to work on. But that being said, you really shouldn't have to work on these very often. And with the service this received, it's probably going to last many, many years without having any kind of problems. So that being said, what are we going to do with this video? This is going to be the final video in this series. And what I thought I would do, I promised you all that we would do all the testing of the receiver. And I think maybe this time what I'll do is I printed out the spec sheet. And what I think I'll do is we'll choose a few of the parameters that, of the specs, and we'll see if we can use the test equipment I have available on my bench and replicate some of those tests and compare them to see if this amplifier can at least meet, if not succeed, or exceed, not succeed, meet or exceed the specs that they originally were shipped with. So looking at the most basic thing, which is power output, everybody asks, when you say I have a stereo receiver or stereo amplifier, invariably the first thing out of somebody's mouth is going to be, how many watts is it? Because watts is everything for some people. As you grow and start to understand audio a little more, I think your opinion of watts will change. I'm just saying that to some of you out there. But anyway, rated power output, okay? And it says minimum continuous average power per channel, and this is the most important part, both channels driven. Now, why is that so important? They're telling you that when these tests were taken, they're driving a signal into both channels, and they have a load attached to both channels. This is a stereo amplifier. There are two amplifiers inside a stereo amp. And the thing is, you can get two very different results when you have when you're driving just one of those amplifiers versus both. Because think about it. If you have a single power supply driving both amps, like you do with this Marantz 2252, you're asking the power supply to deliver double the amount of power when you're driving both channels as when you're driving one channel. So you can make an amplifier perform very well with one channel only, but then if you have an inadequate power supply and you drive both channels to that level, you get a very different result. A very well-designed amplifier will do the same on one channel as it will when both channels are driven. So when they are claiming that they're getting these results with both channels driven, that's telling you that the amplifier probably has a pretty good power supply in it. So they're saying you can get 52 watts per channel when both channels are driven. The power band, okay, so the frequency range that you can get this power is between 20 and 20,000 hertz. So that's our human hearing range, isn't it? And most of the time, the amplifier will go well above and below that with that power band, especially these solid state amps. Now, tube amplifiers, completely different thing, but we're not talking about that today. Total harmonic distortion, again, when you're driving it at 52 watts, you're looking at 0.05% THD. Now, what it's not saying right now is if you're getting 0.5% at that entire frequency range, but chances are you probably will be with this amplifier. A lot of times when they do the THD rating, they'll do it at 1 kilohertz only. So you put a 1000 hertz tone, and that's what they're guaranteeing the distortion. But sometimes if you go above or below that, the distortion figures could get worse or better. And the way this is written kind of makes you think that no matter what frequency you're at, between 20 hertz and 20 kilohertz, when you do 52 watts, you'll get 0.05% THD. I would probably tend to agree with that, but I would say when you start getting down around 20 hertz, we're going to see if we can get 0.05% at 52 watts at 20 hertz. We're going to test that. Now notice when you go to a 4 ohm load, it only goes up to 65 watts per channel, not 100 watts per channel or so like you would think. And that's because of the limitations of the circuitry and the limitations of the power supply. So you're not really driving a whole lot more wattage into a 4 ohm load than you will into an 8 ohm load. And that is that's not always the case. Some amplifiers can deliver a lot more current, and they can deliver a lot more power into a 4 ohm load than they can into an 8 ohm load. This amplifier is not. So just remember, you're only going to get a little more power out of a 4 ohm load. In addition to that, your THD doubles. You can see they're getting that power, and instead of 0.05%, it's 0.1%. So our first set of tests, this might be a longer video, I don't know, because if I explain all these tests, it's going to take some time. But we're going to set up our test, what we have here available on the bench, and we're going to do an 8 ohm test and a 4 ohm test, and we're going to see if we can get these wattages at these frequencies, and if the THD will stay within that range. Okay, amidst all the fans and cooling and everything going, I have my test equipment set up, and here's a rundown of what we have. The output of the amplifier is going over to the speaker dummy load, which is over here, and it's set to 8 ohm load right now. The signal generator, you can see up there in all the glare and everything, it's just set for an audio signal of 1 kilohertz, 500 millivolts RMS amplitude, and that's just going into a Y adapter. You can see the Y adapter and the 2 wires coming down, and they just go into the auxiliary input of the amplifier. And then across the dummy load resistor, we're attaching our 2 meter probes, and it goes into the oscilloscope, and I just have a couple of calculations entered into the scope to make it a little quicker to make measurements. So we're measuring the RMS voltage across the load that we can use to calculate the wattage. And if I'm on the 10 volt scale, if I change the scale it won't be accurate, but if I stay on the 10 volt per division scale, these 2 bars that come up will indicate the wattage, and it will be 10 watts per division. Now I also have the Keithley THD meter set to measure the left channel for right now. I can only measure 1 channel at a time with this. So let's see where we are. And we drive this up, and you can see the wattage, and you have your right and left channel, the blue and the yellow, they're tracking very closely. So that means the potentiometer is pretty good. And you'll see these things will separate on and off. And we're now there's 40 watts per channel. There's 50 watts per channel. There's 60 watts per channel, and you can just see a little bit of distortion. Now it's starting to clip, and we get up to about 65, and that's where you get some actual clipping. And see how it flips up and down like that? That's your power supply. A little bit of fluctuation, and that could be due to a little of that could be reduced by putting a bigger capacitor filter on the main power supply, but won't help a whole lot, just a little bit, but it's way above its rating. Now, let's look, I mean, this looks like a perfect signal. So let's look at the THD meter, and I just have, let's just go about 10 watts per channel right now. And at 10 watts per channel, your THD is very low. It's 0.01. And remember, it's supposed to be 0.05 at 52 watts, both channels driven. And as I go up, there's 20 watts, and I'm already up to 0.1. 30 watts, 0.3, 40 watts. And you can see how it kind of, as I go through the power band, it changes. That's odd. And now I'm at about 55 watts per channel. I have 0.2%. And then when I go into clipping, you can see it goes crazy. But that is odd. That should stay, you know, you've seen me do this test on other amps in my previous videos on other amps. That should not peak and then go back down again. So why is that happening? Let's move over to the other channel. So I'm just going to disconnect the THD meter from the left channel. I'm going to move it over to the right channel. And I'm going to do the same test. Let's go back to here. Let's see if it's a channel related thing. All right, so that's good so far. There's 10 watts per channel, 20 watts per channel, and we're already up to 0.1, 30, 0.3, it's doing it again. 40, down to 0.1 again, 50, and 60. And there it starts to clip. Odd. So is that my test equipment, or is that something wrong with the amplifier? I'm going to have to look at this a little bit more closely because I've never seen that before. I've never seen that behavior of my test equipment. So let me do a little bit of troubleshooting of my setup here and determine whether it's our amplifier or test equipment. All right, this is one that's got me stumped. I'm going to have to think about this. So if I go over to the scope here, now I have the slow scan spectrum analyzer connected, and I also have the THD meter, and I'm seeing what's going on, but I don't know why. Now both channels are doing this, and the right channel is just ever so, well, I can't say that, they're both about the same. If I turn this up until we get a little bit of signal, so let's move this out of the way for the moment, if possible. And I just turn the volume up a little bit. Let's say there's 10 watts per channel right about there, okay? And if I look, right there is very good distortion, right? It's 0.01. And if I look up at the slow scan without the glare, you can see there, and I'm at an angle because I would have to move the camera around, but you can see there's your fundamental. That's your 1 kilohertz right there. And there's absolutely no distortion at all, nothing. Little bit of stuff down here in the noise floor will show up, you know, when it goes through, but really nothing, okay? Now, watch this. If I can get the whole thing in the camera, I'm hoping. And I don't know if you're looking at a full computer screen, you might see it all, but I don't know. So let's go up in volume, and you're going to see this go up. I'm going to hit a trip point where all of a sudden, see, it's just, there it is. See it? Right there. It jumps right up to 0.3%. And if you look, now we have all kind of harmonics. See that? And if I go up a little bit more, it drops. See that, how it drops a little bit? And now you get little side bands on that distortion. And if I play with it enough, I can get it right into a point where, let's see, you got to wait for it to go through. It's a slow scan spectrum analyzer. Let me reset. And see that? And sometimes, depending where I turn it, I'll get little side bands in there as well. Let's go right about there and see what there it is. See them starting to show up? See the little side bands? And then if I turn this back down, and I reset it, you can see I get a couple little ones. And that's it. Very, very strange. Now moving over to the other channel, I just switched over to the right channel. You can see it's doing the same thing. And if I just turn down a little bit, and you can see I'm not clipping or anything. And it drops. And right about there at now 20 watts per channel, it's back down to nothing. You can see once it sweeps through, totally clean. And I go up just a little bit. Okay, now I'm at 30 watts per channel. And there's like a peak to it. So right at about 30 watts per channel is it peaks. And then it drops again when I get above 30. Like, now that I'm up to 40 watts per channel, you could see the distortion is lower. But if I go back down to 30 watts per channel, it gets worse. See that? It's just really weird. Now, I don't know if there's some sort of oscillation going on at very high frequency that I'm not seeing. But I'm going to have to look at that. And could this have something to do with one of the transistors with a choice in one of the transistors I replaced? Because remember, I replaced a couple of the transistors and I replaced them in both sides. This is the first time I've ever seen anything like this happen, so this is kind of a new thing. So I'm going to really have to look at this. Okay, I found a couple of problems, and part of it is my fault, part of it is an error in the schematic, and part of it may be that I just found something that was wrong, but it's still not causing this problem. I still don't know if this would cause this, especially in both channels. And what it is first of all, looking at the schematic, let's zoom in and get a better angle on things. So looking at the schematic, there's 4 electrolytics that I replaced here, and they're 47 microfarads. There's C710 on this channel and 709 on this channel. There's C707 on this channel, more about that in a minute, and C7006 on this channel. And the difference between them is these 2 capacitors are rated at 16 volts, and these 2 capacitors are rated at 50 volts. And when I replace them, first of all, this is a typographical error. It is not C707. It's actually C705. And you can see the check marks I put there. So here's C707, which is a ceramic capacitor. So that's marked incorrectly on the board there, but no worries on that. And you can see there's 2 16 volt 47 microfarads and 2 50 volt 47s. And you can see where I clearly, and I marked them with the highlighter, these two are swapped around. So the 16 volt one should be here, and the 50 volt one should be here. I got them correct on this side. These two are good. So is it possible that this capacitor, when I turn up the amplitude high enough, it's exceeding its maximum voltage and causing that? And since it's common, well, it's not really common because there's a resistor on it. You can see this is coming from the feedback circuit right here, that if this channel, of course with the feedback, you could possibly exceed that 16 volts because this is your speaker voltage, and your maximum voltage on this probably could, you know, in theory will exceed that. So this would be stressed. However, it really shouldn't affect this channel in the same manner, so that's kind of strange. So I don't think that's causing the problem, but it's definitely going to be a problem if I don't fix that. Everything else measures perfectly in here. I don't see any parasitic oscillation. I don't see anything that could cause that distortion to show up or those harmonics to show up at 30 watts and then watch them subside as you go higher in power. It just doesn't make sense. But I am going to put these in the correct way around, and I'll just put two brand new caps in. So, you know, this one and this one, I'll put two brand new caps in case one of them got damaged, you know. And I highly doubt that's going to make any difference, but we're going to try it. Okay, our old capacitors have been removed, and I have the correct one here and here now. I have everything turned back on. Amplifier's been running for a few minutes to warm up. Let me turn on the signal generator, the output. Let's go over to here, and I don't know if I can get this all in here or not. Oh yeah, I'm going to get this light out of the way. All right, that looks like it's all here. Okay, let's take this, get the scale where I want it back so our power meters and everything are accurate. All right, here we go. That's promising. That looks good. Oh, it would help if I'd go to that. Okay. Let's see what it... Nope, still doing it. Still doing it. See that? Right there at about 30 watts. It just goes, it does that. And once I get through it, it settles down. However, when I'm at that 30, okay, I see it. I see it. I see the problem. I did not see that before, but now I'm seeing it. So let me put this up here so it holds the wire out of the way for you. Look very carefully at the very bottom of that waveform there. As I go down, see how it looks nice and clean? Watch as I go up. See it? Just a tiny little bit of oscillation. And you can see it get worse. And then clipping. But you got to have about 30 watts. Right at 30 watts, it kind of goes away. See? See it? We're at 25 watts right there. I go up towards 30. There it shows up. So there is some sort of an oscillation, and it seems to be on both channels. Let me see if I can separate these a little bit so we can see them individually and see if they're both doing it. Let's bring this down, or up I should say, and there it is. See, and they're both doing it. The right channel seems to be doing it more than the left, but they both have it just a little bit. See that? Now I don't know if that's something these things always did, but that's definitely not right. And we're going to get rid of that. That will drive me insane. All right, I think I found another problem. So if you look on the schematic, here's our driver transistors. And you have this capacitor going from the base to the collector. And this prevents parasitic oscillation, among other things. And it is rated, they're listing it as a 100 picofarad capacitor. You can see there's 4 of them. And if I look, it says that is C723 and C725. And if I go here, 723 and 725, all 4 of them, they're 100 picofarad, 500 volt. When I look on the actual board, here are the capacitors. There's one right there. The other one is right here. And if I take a look, I don't know if I can get close enough to see it without it doing the I can't focus thing. But looking right there, that is very clearly a 50 picofarad capacitor. And I don't know if I can get it at a good enough angle to see it, but it is a 50 picofarad. And the same thing here. This one is also very clearly, I don't know if we can get it down here in the camera, it is 50 picofarad. See, 50. I mean, my eyes aren't that good, but I think I can see that from here. So they put the wrong value of cap, but the other thing is, normally when you have those capacitors on there like that, those things are usually directly attached to the leads of the driver transistors. Well, look how far down this is here. I mean, it's attached here, and then you can follow the trace. It goes up, over top of this, back down, into this 0 volt resistor, or the 0 ohm resistor, which is a jumper, over to here and then to there. And then the other end is right here, and it snakes its way all the way around and up into here. So very obviously a huge distance between the capacitor, and same thing over here on this side. You can see where it goes from here up to here through this jumper and then up, and then the other end is down here and again snakes its way around and up into here. So you're really supposed to have those as close to the leads as possible. So what I'm going to do is, this channel is really easy to get to from the back without moving things. So I'm going to first modify this. I'm going to remove these 2 caps, and I am going to replace them with the proper 100 picofarad, because again, these have a real high transition frequency, maybe even a little higher than the originals. So they might be a little more susceptible to that. So we may need a little bit higher capacitance, and it may need to have those 100 PF caps. So I'm going to try that. I'm going to attach them right to the leads from the back of the board, and we're going to see if that cures our problem. Okay, the capacitors on one channel have been installed, and they're now 100 picofarads instead of 50, and they are directly on the transistors. And if we watch what's going on now, and I turn the volume up, I don't know, let's see if we can get this whole thing on screen. Kind of awkward, but we're going to do it. All right, and as it creeps up, it just goes up to 0.1. It still does it, but much less now. See that? As we pass through that, and now it's doing it closer to still around 30 watts, and then it stays down all the way till you almost get the clipping, and there's clipping now. So I think it needs to be a teeny little bit higher, maybe 120 picofarad at the most, But I may leave that in there because I don't know that that's going to be audible. That's just so tiny. So I'm going to install the other side the same way. And just so you know, if I move over to the other channel that's not modified, and you watch the same thing happen, as we get up to 30 watts, you can see it goes up to 0.4% and then sweeps down to, you know, never goes below 0.2 after that. So we're on the right track. And just to make sure everything's okay, at 20 kilohertz, you can see it's holding up good too, but it still has that little bit of harmonics to it. You can see it on the scope. I don't want to run this too long like that, but you can kind of just see where, see it, the unmodified channel and the modified channel. And this is a 20 kilohertz signal instead of 1 kilohertz. So we can still get our high frequency response. We just need to change that capacitor. I'm probably going to move that up to maybe a 120 or so. Okay, I have the capacitors in, you can see, on both channels. And I ended up, I'm going to put in a 200 picofarad cap on there. And that's because these new transistors that I'm using are a lot faster than the ones that I replaced it with. So I need a little more capacitance to cancel out the Miller effect. And of course, Miller capacitance is, or the Miller effect, is what's causing this parasitic oscillation to take place. So this will kind of slow the transistor down a little bit as you get higher in frequency, and hopefully prevent that oscillation from happening. I have a feeling this is something that was going on in this amplifier before, but just not to the degree it is now with the newer transistors. So hopefully this will get it dialed right in, and it'll work perfectly, but only time will tell. Let's get it all put together and then we can test it out. Okay, now for the moment of truth. Let's zoom our scope in. I'm still at 20 kilohertz because we could see it a lot easier there. And let's just bring this up. And you can see there's your 30 watts right around in there. And notice nothing. And you can see at maximum, you know, there's 50 watts roughly. And I'm not going to leave that too long, but look, perfect. And as I go down in power, it drops like it's supposed to. And now it's perfectly functioning. Now let's go back to our 1 kilohertz test. And I have to change my scope. There we go. And let's bring this up. And you can see there's your 30 watts. And it is absolutely perfect. Perfect. And there's your clipping, hard clipping now. And as we go down, it drops like it's supposed to. Perfect. That's what we want. So there's a really good example of why you have to test everything when you restore a receiver. When you just replacing capacitors and transistors is not enough. Any little change you make to it can affect the performance of the amplifier, and you really can't always see that. That would be something that would be hard to hear. With really good speakers at the correct volume level in a correct listening space and all that, somebody who's really listening for it would be able to hear that. But other than that, it's not something you would just see on your bench. And so, again, you have to test everything. You have to use a scope and look for things like that oscillation and so forth. And know that if you replace a transistor like that, if the transistor you have has a different characteristic, especially things like gain or transition frequency or something, it's going to do things like this. And you may have to make some changes to the circuit to compensate for it. This was a lot, these transistors that I used were probably a bit faster than the ones that I took out of it. And as a result, they went into oscillation a lot more easily. But we've rectified the problem, and the amp is working good now. And I think I'm going to just leave this part by itself in the video and show this as an example of how things can go wrong. And then we'll do one last video with the rest of the testing with the amplifier all put back together. All right, so again, peace, joy, happiness, and good health to all of you. And we'll see you again real soon, and I'll get this posted up.